Hello, I'm going to demonstrate Wireshark, nmap, and Hydra using some of my VMs. I've actually got 4 online right now, and I'm running about 10 gigs of memory committed, up from my usual 6. So I've got my Metasploitable, my Kali, my ParrotSec 4.6, and my infrastructure server. The reason the infrastructure server is up is I've got all of these in a LAN segment, because it's really not a good idea to expose something like Metasploitable to the rest of the universe. Thus, I'm going to attack Metasploitable, but only in my sandbox. So let's get started. So I've got ParrotSec up. I've got an IP address from it. I've got my Metasploitable up. I've got Kali up. One thing that I've noticed the other day, I kind of played with the Hydra lab a little bit, which is actually the second part of this. A lot of this stuff that you can do in Kali, you can also do in Parrot. Kali was doing something else at the time, so I decided to try it with Hydra, and it worked quite well. Notice that there's these three boxes up here. On a lot of your Linux distros, those will be a set of boxes like that will actually be for other desktops. Say, for example, like this one. I just popped over to a secondary desktop. So you can organize what you're doing a little better. Say, put all of your apps devoted to one set of tasks in one desktop and another in another environment, and go from there. With ParrotSec, what you actually have up here is performance. Let's see, you've got your processor utilization, your memory utilization, your network. So some basic performance monitoring stuff, so that you don't have to have something like glances running in the background all the time. So, but it's kind of what we're going to do is actually we're going to use, I'm going to do the first part of this with Wireshark and the second part of this with Parrot. The lab is written to do all of it with Kali, but because I've got all of this kind of sandboxed and I've already grabbed the file I need while Hydra was actually connected to the rest of the universe, I'm going to change it up a little bit. Just a second, I'll be right back. So the first piece of information we need is the Metasploitable VM's IP address, which in this case is, and actually let me filter this a bit. IP-4 address show, that'll give me 192.168.112/24. So 112. So what I'm going to do over here, Control-Alt to get my cursor back, go to Kali, and I'm going to go to Wireshark. So that's Applications, Section 9, Sniffing and Spoofing. I'm going to choose Wireshark. And of course, I've got to run, let's see, so provide your own credentials. Let's give it a minute. Alternatively, we could, okay, there it goes, good. Okay, so the first thing we need to do is it's gonna spool itself up, and then we're gonna have to pick a NIC. So in this case, we're going to choose Ethernet 0. Yeah, we don't want to do anything like that. Now, the next thing we want to do, so it's doing some stuff. It's bouncing around. The next thing we do while it's doing this, actually, let me stop that. So something is ARPing for 1.1. So let's pause that for just a second. The next thing we're going to do is ZenMap. ZenMap is basically a graphical front end to nmap. And let's see. For gathering, port scanners, nmap. Let's find, you know what? Let's find ZenMap. Okay, let's do this with nmap. Info gathering. Nmap. Okay. Nmap, of course, takes us. Zenmap is the GUI front end, but we can do this just as easily with nmap. If we do nmap, and I'm going to give this pseudo privilege just to be sure, -sn 192.168.1.12. Now, before I do this, I'm going to go back over to Wireshark, start capturing packets. I will continue without saving, and now find the right one, enter. So it is scanning. So let's go over to Wireshark, see what it's getting. So I see some ARPs. The next thing I can adjust this. Let's go over here. Okay. So this will actually scan the entire range. So I'm going to dump this, start a new one, continue without saving. Now, fire it off. Boom. So it's going to scan the entire range. Let's actually go. Somebody is definitely trying to find 31.2 and 1.1. Somebody's looking for the gateway. Let's go back. Okay, and we'll stop that scan. So we're going to file. We're going to save this as ARP scan. Save it. Now we can apply a filter. Just type ARP. Okay, so let's see what our option. Let's see what we see. Okay, so what this? So it's scanning literally everything. And notice who talks back. 115 response. 1.2 responds because that's my infrastructure server. 1.1 doesn't respond. Let's see how far down do we go. 115 responds again. So yeah, we have effectively scanned the entire. Actually, it scanned all the way down and then restarted. So yeah. Next thing we can do. Now here's the thing. If you see a whole bunch of, if you see ARP scans happening every once in a while that seem to make sense, that's one thing. But if somebody on your network is just ARPing for literally everybody, that's a little suspicious. You would expect the host which wants to talk to each other, unicast, to talk to each other. And of course, the thing is, they don't do that over and over and over again. The ARP cache information resides, the information resides in the ARP cache for a while. So it wouldn't just go out. It wouldn't just be forgotten. And you wouldn't ARP for literally everybody, any more than you would literally ARP for the broadcast and see who else is there. Broadcast pings are suspicious. Broadcast ARPs are suspicious. So we can actually, this just demonstrates one of the many things you can do with nmap and with Wireshark, so you can watch what's going on. Thanks, and I'll talk about Hydra in the next video.